seen big changes in main roads over my time. Gone from a construction and maintenance type of organisation with a large blue-collar workforce to an organisation that is a manager of the road network, with a lot of the work done by, or most of the work done by, contractors and consultants. Seen a big change in the road network around the state, and particularly around Perth over the last 21 years. There's been a lot of new freeways and highways built around Perth to service the new residential areas that have been established. I've mainly been involved with road construction works. Down in Bunbury, my projects were the dual carriageway from Perth to Busselton, which has been extended significantly over the last 10 years. I was also involved with the mineral sands haulage route for the Beanup mineral sands mine down near Augusta, and also the mineral sands mine near Nannup. The existing Narrows Bridge was completed in 1959. Works on the reclamation of the river for the approaches to the bridge were commenced in the mid-50s. The bridge itself was designed by Maunsell and Partners from London, and the contractor was a Danish company, Christiani and Nielsen, in partnership with a local Perth firm, J.O. Clough and Son. That was actually Clough's first major construction job in Perth, and they've moved from strength to strength since that. The first bridge was really many years ahead of its time, which is fairly evident, I think, by most people's comment about the bridge, that it after 40 years it still doesn't look aged. It blends in well with the Perth environment, and really has become an icon for Perth. Well, the old bridge has held up very well over the years. It was a very well constructed bridge and a very well designed bridge. It has had a number of strengthenings done to it over the years to keep its load carrying capacity in line with the current traffic. I believe it's reached the limit of the load capacity that it can handle. But the bridge is wearing very well. There's not really a lot of problems with it. As part of the duplication contract, we will be undertaking some repairs to the existing bridge and cleaning the old bridge up. We're taking the opportunity with the construction of a duplicate bridge, which will enable us to divert the traffic off the existing bridge, to undertake some repairs that are virtually impossible to do at the moment with the traffic running on the bridge all the time. We actually got considerable architectural advice on the matter of the form of the new bridge. We took advice from an architect renowned around Perth for his work with bridges, and also a heritage architect, as well as the Heritage Council. The consensus was that as the duplicate bridge wasn't joined to the existing bridge but was adjacent to it, it should clearly show that it's from the same family as the existing bridge, but should reflect modern construction techniques. In other words, it shouldn't be a 1950s bridge built in the late 90s, early 2000s. So to that extent, we picked up on certain architectural features of the bridge which we wanted mimicked in the new bridge. The span lengths will be the same. The shape of the elevation of the bridge with the arching over the piers will remain the same. The white concrete fascia that the bridge has got will be mimicked in the new bridge, as will the granite curbing that tops the fascia, that will be mimicked. The pile caps of the new bridge will be the same as the old bridge. However, the underside of the bridge will be different. Whereas the existing bridge has 8 beams, the new bridge will have 4 beams. So it'll be a lot more open on the underneath, a lot lighter on the underneath, which people would notice when they drive under the bridges. Because of that, the pier columns will be a slightly different shape, but they will be quite clearly from the same family as the existing bridge columns, and will blend in very well with the existing bridge. All of the approaches are on reclaimed river, so there's a lot of mud below the surface that needs to be consolidated, and is indeed still consolidating from the loading or the reclamation that was done 40 years ago. It's still settling, so we had those sort of issues to encounter. The other difficulties, I suppose, is trying to build a bridge and the approach roadworks adjacent to and amongst a freeway that's carrying 160,000 vehicles a day, which is more than the Sydney Harbour Bridge carried before the Sydney Tunnel was built. We had a set of guidelines set down on the project by the Swan River Trust, and Leighton contractors have been and are continuing to be in close contact with the Swan River Trust regarding the works that they do in the river, and they've had no issues at all with Swan River Trust. They've been very happy with the way Leighton has approached the works. And the works have been designed to minimise the impact on the river with the incremental launch method that Leighton are using. The amount of false work in the river is kept to a minimum. The materials that are used on the new Narrows Bridge are much the same in principle to the materials on the existing bridge. The main difference is in the method of construction. The existing bridge was built of segments that were constructed on the South Perth foreshore and then taken out and placed on false work that had been constructed over the river on timber piles, and those individual segments were then stressed together. The new bridge is using the incremental launch technology, whereby the bridge is built on the bank of the river, and as each 26-metre segment of the bridge is built, it's pushed out across the river by hydraulic jacks. So, as an example, the bridge is being built on the south bank of the Swan River, and the first segment that's actually built finishes up on the north side of the Swan River. So it's gradually, as the bridge is built, is pushed out across the river. The incremental launch technology has been used on a number of bridges in Perth. The recent bridge over the Swan River for the Graham Farmer Freeway was built by incremental launch. The Mandurah Estuary Bridge, the Dawesville Bridge were all built in that manner. However, the Narrows Bridge is, as we understand it, the only bridge of this type that has ever been built by incremental launch. And by that I mean that it's a haunched bridge. It's got arches across its length, and which means you can't use the conventional incremental launch technology, whereby the bridge is supported on the underside during the launch. With the Narrows Bridge, it's actually being supported on the underside of the deck during the launch. So you'll see temporary steel towers are being built across the river to support the bridge on the deck until it reaches the other side. Then it will be lowered down onto its final supports, and the temporary steel supports will be removed. The bridge is cast on land and is lifted and pushed by hydraulic jacks out across the river. The hydraulic jacks are a two-stage jack in that they The jacks lift the bridge by a small amount, then they slide it forward 300 millimetres. The jacks then drop down away from the bridge, slide back, then lift up again, and the process is repeated. Each launch is about 28 metres long. Latent contractors who were designing and constructing the duplicate bridge actually came up with the incremental launch approach for the bridge, which had considerable savings both from a time and a dollar point of view for the contractor. That was developed by latent contractors in conjunction with their designers, Connell Wagner, and it has given them a lot of technical challenges to overcome. They've worked very hard at that, and they've overcome most of those, I believe, and the bridge works are now progressing very well. The objectives of the Narrows duplication project is primarily a public transport initiative. It's the first link in a dedicated two-lane bus transitway that will go from the bus port in Perth to the park and ride facility at South Street. As such, it will provide two dedicated bus lanes, and what we'll finish up with at the end of this project is two bridges, each bridge having a dedicated bus transitway lane on it, 5 traffic lanes and 1 dual-use path on each bridge. So there'll be improvements to public transport. The traffic lanes will see an increase in an additional traffic lane over that's available currently at peak, which will provide improvements to road safety and traffic efficiency using the Narrows Bridge and the approaches. Our statistics show that there's a significant number of accidents that occur on the approaches to the Narrows Bridge, and a lot of that's due to the amount of lane changing and merging that has to occur. The traffic that comes onto the freeway from South Perth, half of that traffic at least wants to go to Mitchell Freeway. To be able to do that, it has to cross 2 traffic lanes. Also in that vicinity, the Kwinana Freeway only has 1 traffic lane that connects with the Mitchell Freeway. After the duplication, the South Perth traffic will only have to move 1 lane to get to Mitchell Freeway, and also all 3 Kwinana Freeway lanes will join up with the Mitchell Freeway. For southbound, the merge areas with Riverside Drive, William Street on ramps and the Mounts Bay Road on ramp, those 2 merges are very, very close together and do cause a lot of traffic congestion. With the additional southbound traffic lane, we're able to bring Mounts Bay Road on its own lane without a merge, which will mean we can reduce the number of merges in that area. I think there is a perception that we're duplicating the bridge, we're duplicating the traffic volume. In fact, when you look at it, the current bridge has got 7 lanes, one of which is a bus lane, reversible peak lane. We have to take that bus lane component out, turn that into 2 bus lanes, turn the reversible peak lane into 2 lanes. Then we're just adding an extra lane in each direction. So we're really only providing 1 additional traffic lane in each direction during peak period, or over what currently exists in peak period. And that's mainly to improve the flow of traffic, to improve the safety on the bridge and approaches.